take a look at some more examples of derivatives of inverse functions. There are a couple of ways to solve these problems. I'm going to show you both approaches. But let's start by looking at example 1. It says, let f of x be x squared minus 3 over x. The first part of the question is, what is the value of f inverse of 8? So first off, we need to have an understanding of what that asks. Well, we know in the world of inverse functions, we know that if f of x is y, we know then that f inverse of y gives x. So in this situation, we have f inverse of 8. So we have f inverse of y. So we want to find the x value that gives the output of 8. So ultimately, what we would like is we would like to find the value for x in x squared minus 3 over x that gives 8. Now, generally, this can be found by really simple guess and check, starting with, say, 0. So we have 0 squared minus 3 over 0. Is that 8? No. Let's try 1. 1 squared minus 3 over 1. That's negative 2, not 8. Let's try 2. 2 squared is 4 minus 3 over 2 is not 8. Now let's try 3 squared. 3 squared is 9, minus 3 over 3 is 1, 9 minus 1 is 8. So since 3 squared minus 3 over 3 is 8, because 9 minus 1 is 8, we have then found the value for f inverse of 8. So we would say f inverse of 8 is in fact 3. Okay, because f of 3 is 8, f inverse of 8 is 3. All right, now part B. We would like to find f inverse prime of 8. Now this can be tackled 2 different ways. I'm going to start by showing you the method I initially taught in class, and then I'm going to show you an alternate way. So we're going to start with taking our original function and writing it as an equation. So y equals x squared minus 3 over x. This is our original function. We are then going to invert it. So we know that the inverse function simply reverses the roles of x and y, right? So x is now equal to y. Okay, so y squared minus 3 over y. Okay, now what we want to do is we want to differentiate this, right? And we're going to differentiate implicitly. So the derivative of x is 1. The derivative of y squared is 2y, y prime. And then the derivative of negative 3 over y is positive 3 over y squared, y prime. Okay, we're going to solve this by factoring out the y prime. So we get 2y plus 3 over y squared, y prime. Okay, now solving for y prime explicitly, y prime is equal to 1 over 2y plus 3 over y squared. Now, if we'd like to clean this up, we can say y prime is equal to y squared over 2y cubed plus 3. And we get that simply by taking y squared and multiplying the numerator and the denominator in order to remove that fraction within a fraction issue. Okay, now one thing we need to note here is that in this case, y is f inverse of x, right? Because y is the inverse function, whereas in the original, y was f of x. So in this function we have here over on the right, we know that this means f inverse prime of x, right? Because y prime is in fact f inverse, right? And this equals y, once again, is f inverse of x squared over 2 times f inverse of x cubed plus 3. So in this case, when we want to evaluate f inverse prime of 8, we will simply take 8 and plug it in. So we have f inverse prime of 8 is equal to f inverse of 8 squared all over 2 f inverse of 8 cubed plus 3. Now we know from earlier that f inverse of 8 is 3. So this is 3 squared over 2 times 3 cubed plus 3. 3 squared is 9. 3 cubed is 27. 2 times 27 is 54. 54 plus 3 is 57. So 9 over 57, which reduces by 3. So that will become 3 over whatever 57 divided by 3 is. So 3 into 57 once, 27, so 9, so 3/19. Okay, now note, this is a somewhat long-winded path to the answer, right? It works, right? But it requires a lot of steps. So I'm going to show you an alternate path. Now, note, this alternate path does not allow you to get the actual inverse function, but does allow you to calculate. So here's what you need to notice. You need to notice that if I have f of f inverse of x, that those two functions undo each other. In the same way that a square cancels a square root, that adding cancels subtracting, and so on. So if I have a composition, f of f inverse, it will just spit back out the input, right? So if f was x squared and f inverse was square root of x, and I plugged in 4, I would square root 4, get 2, and then I would square 2 and get 4. That's what's happening here. So with this knowledge right here, I can create a rule that I can use always. So I'm going to take the derivative of the left-hand side, and that's going to give me f prime, so derivative of the outside function, keep the inside function, times the derivative of the inside function. So that is f inverse prime of x. And then the derivative of the right-hand side, or x, is 1. Now notice this, and I know the notation is a bit odd. If I would like to find f inverse prime of x, that's right here. So if I want that, I need to isolate that. So I need it by itself. So I need f inverse prime of x by itself. So that means I need to get rid of, right? I need to get rid of this piece over here. So I'm going to divide by it. So I get that f inverse prime of x is equal to 1 over f prime of f inverse of x. Now with this knowledge, I can use this formula to do the exact same calculation with less effort, right? So I have f inverse prime of 8 is equal to 1 over f prime of f inverse of 8. Now, we learned earlier in part A that f inverse of 8 was 3, right? So this is 1 over f prime of 3. Now, all that means is we need to figure out what the derivative is and evaluate it at 3. So we have our original f of x, right? Which was that x squared minus 3 over x. Let's find its derivative. So f prime of x was what? 2x plus 3 over x squared. And then we need to evaluate it at 3. So f prime of 3 is 2 times 3 plus 3 over 2 squared. That is 6 plus 3 over 2 squared, so that's 3/4. 6 is how many fourths? 6 is 24/4 plus 3/4. And actually, hold on, let me backtrack. Not fourths. We're not plugging in 2. Let's fix that. Sorry about that. So we're actually plugging in a 3. So 3 over 3 squared. 3 squared is 9. So that's 6 plus 1/3. And then 6 is 18/3 plus 1/3. is 19/3. So we see here, if we jump back, that this is 1 over f prime of 3, but f prime of 3 is 19/3. So this is 1 over 19/3, but 1 over 19/3 is the same as 3/19. So hold on, let me erase that. We get equal to 3/19. And so you'll notice we get the same answer. The path is similar in some ways and different in others. So really it's up to you how you want to tackle these. Okay, I am going to show you a couple more problems that I'd like you to try. And then if you want, you can send the work my way and I can verify them. So give me just a moment. All right, so here's a great one to try, right? If f of x is equal to x cubed minus x plus 2, then f inverse prime of 2 is what? Go ahead and pause the video, give it a try, and then take a look at how I do it. All right, so let's take a look. So we have y is equal to x cubed minus x plus 2. So inverting the roles, we get x is equal to y cubed minus y plus 2. The derivative is 1 is equal to 3y squared y prime minus y prime, just like so. All right, so now let's factor out the y prime. So 1 is equal to 3y squared minus 1 y prime, or y prime is equal to 1 over 3y squared minus 1. Now, recognizing that y prime is the inverse function, we see that this is f inverse prime of x is equal to 1 over 3 times f inverse of x squared minus 1. And then we're just going to plug in what they tell us. So they tell us that we're trying to find f inverse prime at 2. So we'll plug in 2. So we have 1 over 3, and then we have f inverse of 2 squared minus 1. And then looking here, in order to find f inverse of 2, we want to know, when does this function equal 2? Just through a little bit of guess and check, we can see that that is clearly a 0. Noticing that if I do say that f inverse of 2 is 0, I get 3 times 0, I get 1 over negative 1, and I do not see that answer. So I'm going to assume then that in this case it is not 0, and I'm going to try another option. So if I plug in, say, 1, 1 cubed is 1, minus 1 is 0, plus 2 is also 2. So we're going to go with that option because the other one is not quite working. So this is equal to 1 over 3 times 1 squared minus 1. 3 times 1 squared is 3 minus 1 is 2, so our answer is 1/2. Now note, in this case, there are two options that give that same output. And when looking at the graph, you can see that, right? That we have 0 and 1 both give 2. You will notice that in general, we will not use this type of function on this type of problem. We tend to only use functions that are 1-to-1. And because this function is not 1-to-1, this problem is a little bit more difficult. All right, that's it.